So today we are going to talk about how to find the area of a circle using integration. So how we find the area of a circle? By integration you can find a area under a curve. For example, let's say this is x, this is fx. So this is our function fx. A, B is a we are the point in x. So if you want to find this area under this curve, area under this graph, what you have to do is integrate fx by x over this a to b. From this you can get the area under this curve. So now what you are going to do? Find the area of a circle. So in order to find area of a circle using integration, we have to find a function that describes the circle. So now we are going to find the function that describes a circle. Consider this point. The radius r is the same from this origin for the every point. This is r, this is r. So as you can see, we can build up a little relation using this. So if you consider this point, this is the x value and this is the y value. X, y. This is the r. You can see this r is the same around the circle for the every point. For the every single point, r is same. So we can write a relation like this using Pythagoras. R squared is equal to x squared plus y squared. So using Pythagoras, we can write r squared equals x squared plus y squared. Now here have the equation for circle. Now we are going to integrate this and find the area. But here is a problem. This is y, this is x. This equation doesn't have a form where if x equals x plus x squared plus sin x or something. In order to use the integration, the function must be in this form. But in here, equation in the form where r squared equals x squared plus y squared. So I have subject y. So after subjecting y, got y squared equals r squared minus x squared. Y equals plus or minus root r squared minus x squared. So in this way we cannot find one equation. There is plus or minus. So we have to remove one and get only one of them. So let's consider y equals r squared minus s squared. So if you draw this, you will see we don't have the other half of the circle. We don't have the bottom half of the circle. But that is not an issue because we know that the circle is symmetric around this x-axis. So we are going to find the area. So if we find the area of this part, we can multiply it by 2 and get the area of the full circle. And for the make this question easier, we can try another. We can take only this part. So we know that this is 1/4 of area of full circle. If we find the area of in this part, we can multiply it by 4 and get the full area, full circle area. So now we are going to do is we are going to find this area and multiply it by 4. So we found that the equation of this is y equals root r squared minus s squared. So r is the radius of this circle. Now we have to integrate this. What are the values? Here the x value is 0. Here the x value is r. So we have to integrate this from 0 to r. We have to integrate this y with respect to x. So y is root r squared minus s squared dx. How we integrate this? We have to use substitution. We have to use a substitution for the integration. Why? We don't know how to integrate a root directly. So we are going to use x equals r sine theta. Why r sine theta? So by using r sine theta, you can see, if I do the substitution, you will get this is our equation r squared minus s squared. When you do the substitution, r squared minus, so x is equal to r sine theta, r squared sine squared theta. So we can take r out, 1 minus sine squared theta, sine theta squared. So we know that cos squared plus sin squared is equal to 1. From that we can identify that cos squared equals to 1 minus sin squared. So we can substitute that. So root of cos squared is cos theta. So we got r cos theta. So in this way the integration become very simply. But when we are substituting, we have to substitute dx part also. So now we are going to find d theta. In order to do that, we are going to get the derivative of this. So I am going to theta. So r is a constant. Derivative of sin theta is by theta is cos theta. So we got that dx is equal to r cos theta d theta. So we found this, and we found that now our equation is equal to r cos theta. So now we are going to substitute. When you are substituting, you have to substitute the limits also. So at x equals 0, what is our substitution? X equals r cos r sin theta. So when x equals 0, equals r sin theta. So theta equals 0. When x equals r equals r sin theta. Sin theta equals 1. It means theta equals 5/2. So now we have all the substitutions we need. So this is 0, this is 5/2, and our equation is r cos theta, and dx is again r cos theta d theta. We got 0 to 5/2 r squared cos squared theta d theta. So this is much simpler, and we know how to integrate this. So how to integrate this? We have to use the equals cos square theta equals cos 2 theta plus 1/2 equation. So we know that cos 2 theta equals 2 cos square theta minus 1. So if you substitute it, you can see we will get cos square theta on other side. So we can write that cos square theta is equal to cos chi theta plus 1/2. So we can put it here. 0 to r squared 5/2. I can get the 2 outside of this integral because it is just a constant plus 1 d theta. I can split the integration for 2, and now I get integration of cos 2 theta is sine 2 theta over 2, 0 to 5 over 2, plus integration of 1 is theta, so theta 0 to 5 over 2. So in here we got sine phi and sine 0, and both are 0. Because of that, this is 0. We got sine phi over 2 minus sine 0 over 2. So both are 0. This is 0. This is also 0. So whole thing is becomes 0. And for this part, we will got phi over 2 minus 0. So we will get the answer as phi r squared over 4. So this is the area of this part. So in order to get the area of the full circle, we have to multiply it by 4. So if you multiply phi r over 4 divide by multiply by 4, you will get phi r square. So this is the famous equation of phi r square. So that's how we get. So that's how we find. So that's how we find area of a circle using integration.